is different. Right? So this way we see that natural intelligence, which comes with the help of what? Biological neural network. With the help of this, we attain the intelligence. So with the help of this, we get natural intelligence. Okay. So, and on the same lines, we can say this human beings also attain the intelligence, natural intelligence, right? So all these are fine, but this intelligence that we have just discussed was because of biological neurons. Now, what if we would like to make the machines intelligent, right? Or we want to artificially create intelligence. When we say intelligence again, it means what? We want our machines to learn. That is what is the foremost desirable ability of any non-living being system, right? So it means what? It means we want to artificially embed the intelligence into the machines. How to do that? First of all, this learning is artificial. This learning is man-made. This intelligence, of course, will be man-made. So this we call as artificial intelligence, right? This is also called, because this is going to the embedding to the non-living being systems, and these are called machines, right? So you can call this as machine intelligence. So either artificial intelligence or machine intelligence, right? So what is artificial intelligence in a very crisp sense? Very few words is here. What is artificial intelligence? Artificial intelligence is nothing but mimicking the human intelligence in non-living beings, right? So it means what? Whatever human beings can do, the machines can also do, right? It is very difficult, it is not easy, right? But at least some of the activities that humans do, if the machines can also mimic the same, we would call the machines artificially intelligent. Okay, so artificially created capacity, please understand here, artificially created capacity to make non-living beings or machines, right, learn to mimic the human intelligence. This is what is artificial intelligence. It is created artificially, right? And when we say artificially, then again, if we talk of the natural intelligence, it was the biological neuron which was helping us to gain the capacity of learning and thereby making us intelligent and to be called as naturally intelligent or intelligent, right? Here, again, if we want to embed intelligence into non-living being systems or machines, we have to have the similar kind of elements, similar kind of setups, similar kind of like we have biological neural networks, we should have some kind of networks or some entities, some processes, some systems which could manage to artificially embed the intelligence into the machines. So this is what needs to be understood. So in living beings, we have only biological neurons, and that is what we are utilizing for learning. But when we move into the artificial set of intelligence, then we may have so many such strategies, so many artificial uh, entities which could manage, at least which could try to manage, which could up to some extent be able to manage to create or and embed the intelligence into the systems or machines. So now up to this stage, I hope we understand that what is AI, what is artificial intelligence, what was the natural intelligence, what was the learning, what is artificial learning, and like that all these terms we understand. Okay. Now, why should we create artificial intelligence? What is the need? Why unnecessary we are uh, going forward and trying to embed intelligence in machines? What is the benefit? Why should invest in artificial intelligence technology? Right? There are so many factors, but out of these factors, we have here only three very impactful, three features. And these features are, if we embed intelligence into the machine, what we get is here. Machines do not require sleep or break and are able to function without stopping with same efficiency. What does this mean? This means that if mans are required to do certain tasks, right, and if it is for a long time, the machines, or let's say a man would need some break, or if the man has uh, let's say gone through for several hours, will need sleep, right? So like that, man has certain limitations, right? I would say workmen will have certain limitations. Whereas if we embed the intelligence at least with limited intelligence for carrying out that task, the machines, if these machines would replace the man for carrying out that task, the machine will not require sleep, breaks, etc. Right? And other than that, the machines will be functioning without stopping. And again, very important point here is with same efficiency, right? Whatever efficiency we have designed the machine for, with the same efficiency, the machines will keep working. So exactly on the same lines, right? Like we design a machine, and if we embed intelligence into the machine will repetitively will keep on doing the same task without even getting bored or tired. So please understand here the second point as well, that here the man will definitely will get bored or tired, and the efficiency will get hampered. In industries, what happens? See, we have a quality control department. So we have a quality control check for each and every manufactured product, right? So even if the machine has prepared a particular product or the object, it is not necessary that will go to the market. Once the quality is up to the mark, then only the product will go into the market. And the product that goes into the market will only account for profit generation. Even when the machine has produced certain object, certain product, it is not necessarily going into the market, right? If the quality is not up to the mark for that product. So that is why the quality check is there. So when we say the quality check, if the let's say man is working continuously for hours and hours, will definitely be going to make some mistakes, and this mistake will deteriorate the quality of the product that he is working on or that he has worked on. So this way, again, the quality will get hampered, and this product may not be going into the market, and that's how the productivity will get affected if the work is carried out by the workmen only. So that's how more and more machines are needed to replace the workmen in order to increase the efficiency of the industry, in order to increase the productivity and thereby the revenue, the profit, right? And again, there are safety concerns as well. Let's say the workmen are very tired, are bored, they may not be able to work properly, so they may make mistakes and causing the accidents, and there may be again the social concern. So here also we see that the machines are desired in industries, because industries products are being manufactured continuously. So these products basically needs to be with the acceptable quality before it can go to the market. And as I said, these products, if it is going into the market or to the end point, then only these will be accounted for the productivity. Otherwise, this will be considered as if nothing has been done or it was not produced. So this is why we go for automation, right? So first of all, we don't want human involvement more and more for this repetitive task, for industrial production, because same kind of product normally is kept on producing. So here lots of human related social issues and other issues come, and we always want to go for automation. When we talk of automation, automation is nothing but it is the reducing or the reduction of the human involvement, or maybe I would say the automation is the towards the machine's involvement more, or replacing the human by machine, right? So this is the basically the automation. This is the main goal of automation, that machines should be replacing the human involvement in any process or the activity in industry. So this way we look at the automation, but again there are dumb automation and intelligent automation, right? Dumb, when we say dumb automation without intelligence, right? You just design a machine and you just give a control of this machine to human beings. Again, the similar kind of problem may come. So the machines should be able to look at the situation and should learn to make decisions, right? Like autonomous car, and similar to autonomous car, there may be machines which just by looking at the product, whether what could be needed and what is the condition of the product or the finish of the product or something like that, based on that it could take the decision. No involvement of human being again. So right now mostly we have dumb automation, but with the help of artificial intelligence we are heading towards intelligent automation, right? So what is intelligent here is the involvement of artificial intelligence, right? And who creates, how do we create artificial intelligence? We use certain artificial intelligent agents which helps us in preparing the artificial intelligence and embed in the non-living beings in order to create the artificial intelligence in the machines, right? So if we have such machines, right, which let's say has artificial intelligence, so these machines will be able to carry out the dangerous tasks where the human life is at risk, right? So this way we feel that artificial intelligence has very large set of applications, and with the help of artificial intelligence we can achieve so many targets, so many aims. So like that we see the artificial intelligence is very helpful. But yes, of course, we are at a stage where we are moving ahead. We don't have the systems, we don't have the agents which can completely mimic the human beings in order to completely transfer the intelligence from human being, or as long as the or as much as the human beings do, the machines will do, like that. It is so far it is not possible, right? But yes, of course, in future we can think of that this can also happen. When we talk of artificial intelligence, so here is the beginning. Many of us have learned in artificial intelligence that Allen's Turing machine is one which basically answered the queries of human beings. And Allen basically helped us in by developing the universal excuse me. So universal computing machine. And here this computing machine basically based on certain logic answered the queries of human beings. So it was 1937 when universal computing machine was developed by Alan Turing. And before that, so this was the start of the artificial intelligence time when we, in terms of the technology. But otherwise, philosophically, if we go even before that, lots of literatures we find that this artificial intelligence mentions are there. So in this journey, right, we see John McCarthy, who coined the word artificial intelligence in 1955. Before that, whatever was there was artificial intelligence activity, but the name artificial intelligence was not being used. So it was John McCarthy who coined this word artificial intelligence in 1955. So let us now quickly see who is responsible for creating artificial intelligence, right? So how does we get the intelligence created? So in artificial intelligence, so as I mentioned already, that this is the artificial intelligence is created by certain mechanism, certain algorithm, certain systems, right? Because everything is artificial, nothing is natural here. But our goal is to mimic the human activity, human behavior, right? Like humans are intelligent. So human intelligence we have to mimic into the machines. So there are some agents and which are responsible for getting themselves learned, and these agents, when you embed into the machine, so basically by learning they attain intelligence. And then since everything is artificial, we call this as artificial intelligence, right, which they attain. Again, the grade of intelligence, the level of intelligence depends on many factors, right? The kind of strategy that we are using, the kind of model that we are using, the kind of situation in which we are working. So, and again, the problem, etc. So there are so many factors, but these are the intelligent agents, the type of intelligent agents that are responsible for attaining the intelligence. And when these are embedded into the system, non-living being systems, they get the artificial intelligence in order to carry out certain tasks for which these intelligent agents are trained on or learned. So, first one is the simple reflex agent. Second one is the model-based reflex agents. Third one is goal-based agents. Fourth one is the utility-based agents. Fifth one is the learning agents. So simple reflex agent. So basically, what is an agent? When we talk of AI agent, so in any AI agent is basically can be understood by simply we have environment, right, with which it has to work, right? And here we have AI agent. So what happens when this AI wants to work with this environment, right? Or the target, it could be a target also, right? So we have certain percepts. And these percepts are through what? Sensors. Either a single sensor or a set of sensors. And based on these percepts, this AI takes the decision. When we say takes the decision, means it generates certain output. And this output is implemented through what? The actuators. So there is either a single actuator or a set of actuators, right? So through actuator, it implements the decision. And that's how this AI is working. Right? So AI agent, artificial intelligent agent. Right? So as I mentioned, this agent could be, you see, this agent could be either of these types. It could be either simple reflex type, or it could be model based, it could be either goal based, it could be utility based, it could be only learning based, or I would say all of these four types, any of the four types, and then further we learn these models in order to improve its performance. So normally this is how it is done. Like we have a simplex reflex agent, and then we use learning agent along with this in order to make in order to improve the performance of these agents. And this way we call this as a simple reflex learning agent. So this is how we develop the intelligence for certain process, for certain targets, for certain targets. So whatever target that we have, whatever process that we have, and whatever activity that we would like our agent to do, we learn. And again, based on that, first we develop and then learn, and then based on that, we interact with the environment, right? And we actuate accordingly based on the percepts. So AI agent has the intelligence, right? So this is where the intelligence is. Please understand. Intelligence is here. These are the hardwares. These are the actuators, sensors. All these are hardwares. They are certain sensors. They take the inputs, and these are the outputs. Basically, this is the output. These are the inputs. So this is what we, with the help of AI, do. If I take an example of autonomous car, This is autonomous car. You see here, this is autonomous car. If I take AI agent and I say so it has to interact with the environment, right? So here, this environment is basically the world where it is running. So this is the road, right? And this car has to move. It has to run. It has to move from one location to another. And in order to do that, it has to have certain sensors. And these sensors basically will keep on taking the parameters. They will be measuring various parameters, whatever parameters they will be using the camera for making the depth, for taking the for measuring the depth, or in order to avoid collision, they will be having the sense of depth also. So there are so many parameters that are needed to be sensed through these sensors, and these go into this box, the AI agent. And AI agent is already learned through experience, because this agent has already already learned based on the experience in the past, like we naturally do. And then accordingly it takes decision. It actually moves the steering. It operates the brakes. It operates accordingly the engine, right? So that is how these AI agents help in order to embed the artificial intelligence in any machine or non-living being system. Now, let us look at the major learning agents. When we talk of learning agents are nothing but any agent which are artificially created, but they have the capability to learn or update the parameters, or they help others to do the same. So it was the year 1942-43, the McCulloch and Pitt, they created a computational model for neural network, right? So they did what? They basically created a mathematical model of a biological neuron. So first of all, they realized that since the biological neuron is responsible for the intelligence, right? So why not let us first understand how does that biological neuron work, and then based on that you create a mathematical model of that neuron, which is called a artificial neuron. And since in the brain we have no less than tens of thousands of neurons interconnected to make some network in order to carry out certain processes for certain activity. So that's how here also in analogous to the biological neuron, we have the artificial neurons, which are connected, which are interconnected, either through feed forward or through any other topology, right? Similar to that, they are also involved in carrying out certain tasks. And they are also interested in getting learned. But here, unlike our human brain, here the capacity is very limited because of the computational efforts that are needed. So for even a single task to be carried out very effectively, we need a network of the neurons that is called artificial neural network. This is what is exactly the artificial neural network, because we have created the network of artificial neurons. So that is what is called the artificial neural network. Now, again, the learning has to happen, because just having the model will not help unless it has to be learned for certain processes. So this model has to be learned. Means these parameters have to be learned with the experience under which it has taken the input output data. Experience means nothing but if nothing but the pair of the stimulus and response. This is in terms of either the number of anything, right? So this experience is used for learning the neurons, not only the neurons, the neural network, right? So this is how a neural network works. It was in 42, 43 where the first model came, right? First, the mathematical model came, right? And it worked exactly same as our biological neuron works, right? And this helped us a lot. And now still we are carrying out the learning through these artificial neural networks. It is becoming very, very popular. But the issue here that we came across is the learning when we have the network little bigger than what we are usually learning with. So here the issue is that we are not able to learn the networks which were really needed for complex processes, right? Managing with complex processes. So these networks basically needed better strategy of learning, which were not possible earlier. And normally, back propagation algorithm, which you must have come across, was used. And when you increase the number of layers, the back propagation was not basically helping us because of multiple issues like vanishing gradients and all, or even random initialization. So with the help of deep learning algorithm, this problem is also sorted out. So let us now quickly move to the next milestone, which was in 1957, where perceptron was proposed. And this is perceptron. Do not go to the name. Name is different, but it is nothing but it's kind of neuron, right? So it's a neural model, right? So, but here the difference is that this model is able to segregate the data, right? And it is because of the activation function, which is binary and linear, right? So if we have any data which could be segregated, it's kind of, we can draw a linear a line, right? So this perceptron will be able to help us because it has the activation function, which is of this kind. So that's how it is called perceptron. Means the neural network which could either say that, well, yes, this is yes or no. Only binary characteristic that it can segregate with. Then comes the genetic algorithms in 1960s. This also helps us in embedding intelligence. So all these are basically the learning agents. Please understand. And these learning agents are responsible for creating the artificial intelligence that could be embedded in any machine or system. So in 60s were very, very, in terms of the propagation, in terms of the contribution of artificial intelligence, right? Because here, in 60s, like in 65, Professor Lotfi Ejade proposed fuzzy logic concept, right? Similarly, Ivanko and Lapa, he proposed the deep learning. Although deep learning is popular now, but the term deep learning was coined in 1965. So now you understand as to how deep is deep learning, means how old is deep learning. So deep learning strategy was, the deep learning network was basically with which the deep learning was proposed. It was done by Ivanko and Lapa in 1965. Then in 1970s, you see, the evolutionary computing came. Okay. So likewise, so many other strategies used to come. So now, as we have already discussed, the mathematical model of the biological neuron, right? So now let us look at the mathematical model, which is analogous to the biological neuron. So you see that we have the biological neuron here is biological neuron. Okay. And let me use some different color here. So this is a single biological neuron, right? So this biological, any biological neuron basically will have these essential characteristics, essential, activities. So first of all, this biological neuron will have the dendrite, right? What does this dendrite do? Dendrites basically collects signals as input, and these inputs, these input signals are summed up, right? Added, and then the summed up signal is passed through the nucleus, right? And this nucleus has certain fluid, right, through which it passes, right? So, and this nucleus is here in the cell body, right? So we have the dendrite which takes the input, right, from multiple sources. It could be even the output of other neurons, right? So these are the signals that are coming through dendrites and getting summed up. And when and since this is passed through some fluid, we call this as the analogous to the filter, we call this as activation function. So again, if the output is more than certain threshold, then we get the output spike here. Please understand, the output spike here. Please note that we do not get any analog signal as the output on the axon. Whatever be the kind of signal that are present at the dendrite, we always get only the spikes. And the spikes maximum frequency is up to 100 hertz only. In 1 second, we can have only 100 spikes. We cannot have more than that. Even it can be less than that. All right. So that is what is the limitation of our brain. So we'll get the spikes like this. Okay. So in 1 second at the max, we can get 100 spikes. Right. And that is again based on the threshold. Right. So if it is based on the input and the threshold. So if the input is more than certain threshold, then we'll get the spike. Otherwise, we won't get anything, right? It is not going to give us any value. So now, through this axon, which is the output cable, right? Output line, right? So yes, you can see the impulses here written. So these spikes can also be called as impulses, right? So you see this again through axon, the signal is coming. And then it is available to these terminals. You see here, this is called axon terminals. These are called axon terminals. These are also called axon buds. So these axon buds have these signals available in terms of the potential, right? The voltage, right? Now, this is a single neuron. And as I said, for carrying out any process or any activity, the biological neurons are normally connected together. Tens of thousands of neurons are connected together to carry out even a single process. So obviously, the output of these neurons, which are available at the axon buds, axon terminals, these will be connected to the dendrite of other neurons. All right, so like this. So let's say other neurons are here. So these are the dendrites which are connected. Okay. So what happens? that the connection between the dendrite of the successive neuron and the axon terminal, this is never a hard connection. Please understand, there is no hard connection. No hard connection. Right? What is a biological neuron? Right? So, when we say hard connection, no hard connection, it means whatever voltage that is available here, please understand, here is not completely transferred to the dendrite of the other neuron. This is not transferred. Right? So, there is no hard connection in between the axon bud and the dendrite. We call this as the soft connection. Right? And again, the amount of transfer of this voltage, the potential, to the dendrite of the other neuron will depend on the density of the neurotransmitters. That is what is very important to know. So, obviously, let's say we have a 1 volt here. Although 1 volt will not be there, but just for your understanding, let's say some voltage will be there. Let's say X volt is there, right? X volt. And this is connected to some dendrite, right? So this X volt will not be transferred directly here, right? Because the connection is not hard. Had it been hard connection, of course, the X would have come here. But this will not be transferred. The complete will not, the amount of potential will be lower than what? The X. So let's say this is X2 and this is X1. So sorry, this is X1. So this X2 will be less than what? X1. Right? How much will it be lower? That will depend on the density of the neurotransmitters in between, present in between the particular dendrite and the particular axon bud, the combination. That is why this W factor is coming. Otherwise, there was no need of W, right? Because this basically decides what is the amount of signal that is getting transferred through this soft connection. Okay, so this way, this axon terminal transfers the voltage to or the signal to the other dendrite. Now, this is what is the working of a biological neuron. Now, let us move to the artificial neuron and see how does it work. Okay, so analogous to this cell body, we have the cell body here. You see the mathematical model, and we have analogous to this. We have see first of all, these inputs are coming in with certain weights because we have to have the multiplied the signal with some weight, because it is going, the X1 is not going to completely come from the cell, the axon buds. So that's why we have to have the W1 associated with X1. And please understand, these W's are called the weights, and the values that it can take is always in between 0 to 1. No more than that, no less than that. Okay, so the W's weights will be, I will write here WI. So like that. So this is why the values of the weight always remains in between 0 and 1. Okay, so once this is done, now let us look at the signal that is getting added. You see here, summation WXI, summation of WXI into WI. So when this is getting added, now we have the bias also B. Right? So many times what happens, we need some factor, some DC level to add the the amplitude, to add the level, right? The variations are fine, but the level may not be there, right? So where the so this way we add some value. So that is why the bias level is there, right? We do not know what level we are working, but variations we get through this. So this way we get the bias, some value, whatever comes here, the total is passed through the cell body filter, and this is nothing but this F, right? This is the fluid which filters, right? So this has been represented by some activation function, right? So this function can be any kind of function like sigmoid or tan H or whatever, right? So it depends. This also normally is learned, and then based on that we get some output. So this is what is the activation function here, and based on the threshold we get the output value which is available on the exon. And if there are multiple exons associated or connected, then every bud or exon terminal basically will have the same potential, because this is a potential. This is not a current which will be divided. This is the potential. So every bud will have the same potential. Whatever potential is coming over here will be available at each and every node. So this is how a biological neuron works here, and analogous to this a mathematical model is prepared. Now we have certain parameters here. W parameters means these are called weight parameters, and then we have the bias parameter, and then inside the activation function, you see here we may have other parameters. All these parameters are learned from the examples are experienced, right? So when we have suitably learned through some strategy, either back propagation algorithm or maybe deep learning algorithms, and when we have appropriately, suitably learned these parameters, we can call this that it is ready to work. And since this neural network has been, let's say, trained for certain process, carrying out certain tasks, then of course we can call this that when we input some data, unknown data, right, which this model has never seen, right, it is going to give us some appropriate, some suitable output, right? And that's how, and that's what our brain also does, right? Because we right from the childhood are training training brains with our experience, day-to-day experience, right? And we keep on modifying the parameters which we do not notice, but we, in order to take better decisions, we are tuning ourselves. Right? On the same lines, the artificial intelligence also are enhanced through the tuning of the artificial intelligent agents by tuning its parameters associated. So neural network is one, and then we have other artificial intelligence. So I will not be going to other artificial intelligent agents, learning agents. They could be based on any model, any strategy that we just discussed, like fuzzy systems or evolutionary computing or maybe genetic algorithm and all. But here, let us look at the issues that a neural network faces, right? And what neural network basically could manage to do and what it cannot manage to do. So if we have a neural network, let's say, when we say neural network, it means some neurons connected together, some artificial neurons connected together for carrying out certain tasks. So here we have a topology, and if this is the way neurons are connected, we call this as the forward topology, right? So we call this as feed forward topology. The first neuron layer you see here, first layer is normally called as the input layer. So this is what is the input layer. And then we have the output layer. And in between we have layers which are termed as what? Hidden layers. So these are hidden layers, right? So this is what is the feed forward network. Now, what is the problem? So with this, we have, for training these networks, we have a very popular algorithm called backpropagation algorithm. And this is the only algorithm which is being used for training any neural network, right? This has a gradient descent or some other suitable optimization algorithm. And based on the error function, you proceed back and change the or tune the parameters in order to perform this network for better and better, right? So this is fine because up to some extent, and since other strategies are available, so this works well and you have to accept it. But there are issues. What are the issues? Issues are when you increase the number of hidden layers, right? And these are needed for complex processes. When you want to model or when you want to embed intelligence for complex models. When we say complex, it means highly non-linear or highly, the process under highly noisy, right, or under uncertain conditions. So if we want to model such systems, we have to have more and more hidden layers, more and more hidden layers. Right? Because more hidden layers, see, basically hidden layers are doing what? Hidden layers are actually mapping the input, whatever input is coming. If it is in some dimension, it is increasing the dimensionality, right? So we know that any data which is non-linear in lower dimension, if we map it into the higher dimension, it definitely would show us to be the linear. It increases the linearity, right? So that's how the more and more hidden layers will help us in properly visualizing the data. So what are the problems that we face here with the number of hidden layers that we have increased? So backpropagation algorithm we used to apply. So here basically the problem is the random initialization of parameters like weight initializations randomly, bias initializations randomly. Because of this, the global optima is not guaranteed, right? So that is how we face this issue, number one. Number two, because of the more and more number of hidden layers, we may face with the gradient vanishing, right? Or vanishing gradient issue. So because of that, we may not be able to learn the network properly. So it is mentioned here the random initialization and then densely connected networks. Because of that, you see the difficulty in training the number of hidden layers as the number of hidden layers increases. In backpropagation, the gradient is progressively getting more dilute. That is, below top layers, the correction signal, right, is minimal. So this is called gradient vanishing, right? Vanishing gradient. So to get stuck in local minima, right? A random initialization does not guarantee, right? So that is another issue. What is the problem? What is the solution? These were the problems. So solution is we should have some strategy which could help us in avoiding such situations, right? Like the deep learning, right? The back propagation, instead of back propagation, the deep learning has come in 2006. And this does what? This actually helps us in managing the parameters, initialization parameters, right? It computes. And the same parameter, if you use, right, this is not creating such issues, number one. Number two, no matter what number of hidden layers we use, this is the learning will perform. So deep learning is not limited to in the number of hidden layers. So that is very, very interesting, uh, development in this area. So deep learning is here. You see, this is the network which was used initially for when the deep learning was proposed by Ivanko and Lapa. So we'll have 2 more minutes, and then we'll move to the question answer session. So you see, this deep learning helped us in managing these issues that we have just discussed. So the first deep learning model, as I already mentioned, that was proposed by Ivanko and Lapa in 1965. So, but very interesting thing here is that time the backpropagation algorithm was existing, because backpropagation algorithm was proposed somewhere in the beginning of the 60s. But even then, the backpropagation algorithm for this network was not used. Rather, some statistical learning was used for training this network. It was because of the backpropagation was not very mature, right? So because of that, it was used. No, then you see the time where this deep learning algorithm is more popular is 2006. And before that, we need to understand that deep learning is the strategy. Deep learning is not only for neural network. It can be used for any network, right? Having any node, right? Either linear, non-linear, but obviously should be used with non-linear nodes. The reason is that the data we use the computational efforts only for worthy problems, and worthy problems could be handled by when we use non-linear nodes. So it was the year, you see, 2006, when Hinton, Bengio, and LeCun, these 3 very high-grade researchers who used to work in these areas for years, they came up with three strategies, right, of learning a bigger network. Bigger means the hidden, where hidden number of hidden layers are more, right? So deeper network. So these strategies were able to manage the learning effectively, and with this we were able to manage. We were able to model the processes very effectively without even coming into the local optima, and we can avoid local optima. And not only that, we could manage to very effectively, more accurately, the model the processes. And since 2006, you see, these models are very much in use, and you see this area is exponentially, the use of deep learning is exponentially growing, right? So any of you who are interested in deep learning area can also go through further literatures and understand these better. So with this, I would stop here. In case of any question, we'll be able to discuss here. Thank you.
Thank you, sir. Thank you for this wonderful lecture. Sir, some of the questions. One question is asked from Vijayan Sharma, sir. How can we optimize deep learning algorithm?
Wait. Let me share the screen first.
Okay, sir.
Yes.
Yes, sir. Sir, the
So,
first question.
yes. Who is asking the question? Let that person ask the question directly.
Okay, okay, sir.
Yes, sir. This is
First, show
Rajnish.
your face. First, show your face and talk to me.
Yes, I am online, sir.
You are online. What is your name?
Rajnish Jain. Sir, my video is also on. I am from
Vijayan. I am
Karyavar.
not able to see your face.
I think there might be some issue. Sir, I, I can
No,
pin also.
first you get corrected your environment and then we'll discuss, right? I would like to see with whom I am discussing.
Yes, sir.
Any other question?
My face is visible, sir. I have pinned my this login also. So I don't know why it is not.
You increase the lux, right? You
Yes,
increase,
name
yeah,
my
you
name
increase
is.
the light before you. So then you will be visible. Okay.
Okay.
Yes.
Okay.
Anybody else who would like to discuss?
Hello, sir. My name is Vijayan Sharma.
Vijendra Sharma. Where are you?
Yes, sir. Now
Vijay
my
Sharma.
camera is on, sir.
Yes, please go ahead, Vijay.
My question is, if the number of hidden layer is increased, then the computational capacity should also increase. That means the output obtaining time will increase. So my
Yeah.
question is, how can we delay this? How can we optimize the algorithm so that the output getting time is getting short?
No, no. See, please understand that. See, why? First of all, uh, what is the problem with the normal learning, which the deep learning is able to manage?
Yes.
So, right. So, but here, the when you talk of optimization, right? So
Yeah.
it is very difficult to optimize the deep learning network, right? The only thing that you can do is you can start right from the beginning, and you can just start with the minimal network, and then you can move. There is no other strategy, right? So, but the cost here definitely will be little more because you want to model the complex, more complex process, right? So there is there is no such algorithm which could give you the optimized set of structure. So far, I have not come across any of such. But yes, we have some transfer learning strategies, right? Let's say we have less data for some process to learn, right? Then there we use transfer learning, means the model remains the same, but the data. So basically here the model computing strategy is not optimized. It's the data which we need sometimes. I mean, it's not need, but yeah, sometimes we are left with very small chunk of data. Then here we deal with that data by using the features that are already learned, right? So that way we get help by using the transfer learning strategy. Okay.
Thank you, sir. Thank you.
Yes, sir. Am I audible, sir? My video is also on. And very good afternoon, sir. This is
Rajni,
Rajnish.
I'm not able to see your face, but yes, you can go ahead.
Yes, sir. This is Rajnish Jain. I can see you very nice. So my question is, yes, sir. My question is, sir, can we apply this deep algorithm techniques in document or text clustering also? Or if it is so, then what are the latest models in this area?
See, I have given you a very brief introduction, right? Deep
Yes, sir.
learning has
Yes, sir.
become very vast. So for
Yes,
that, you have to go through the literatures, right? You have to just go and dig out what is good for you.
yes, sir. Yes, sir.
So it depends what kind of problem you are working on. You just try and first you read some of the literatures of deep learning, then you would understand how you can apply.
Okay, sir. Thank you, sir. Thank you, sir. Okay, sir.
Thank you.
Any other queries from participant? Yes, ma'am, please.
Hello, sir. I am Dr. B. Jayashree from Textile and Engineering Institute, Ichilkaranji. Sir, ours is an autonomous institute, and we are having all autonomous syllabus. And our electrical engineering will be stepping into fourth year in the next year. We would like to have artificial intelligence subject as an elective in electrical engineering. Sir, can you give us some guidelines so that our students actually appreciate that syllabus?
Sure. Definitely. So we can talk this separately sometime. This is not the right forum where we should talk this thing. So yeah, this needs proper discussion, right?
Okay.
Definitely, AI is being run as elective in multiple places. So this is a very good move. If you want to start, it is very good. And now there is a time when we people start gearing up for artificial intelligence, teaching our students.
Okay, sir. Thank you. Thank you. So, can I have some conversation with you, sir, on mails later on?
Yes, mails. Yes,
Okay.
definitely. We can decide some time and then we can discuss. Which college are you from?
DKT is Societies, Textile and Engineering Institute, Ichilkaranji, Maharashtra, Kolhapur district.
Okay, sure, definitely.
Thank you, sir. Thank you.
Any other queries? Please.
Sir, how can we reach you for some guidance? Is there any contact detail?
Who is speaking?
This is Rajnish Jain again, sir.
Rajnish.
Yes, sir.
Actually,
Actually, sir, we are organizing one international conference also in this area, artificial intelligence.
which college
So,
are you?
it is on March 13, and I am from IMS College, Ghaziabad, sir. So I want your guidance in that area also.
Fine. So you can write to me if I am free, then I'll definitely contribute.
Yes, we have already sent you one email on your email ID
Okay.
and requested you to be part
I'm
of.
really sorry. I get tons of emails every day. It is difficult to reply immediately. So I'll definitely look at it, and then if the time permits, then I'll definitely.
Yeah, thank you, sir. We need your guidance in organizing this conference as a member of advisory committee, if possible, sir.
No, but this conference is being indexed where? Which IEEE or stringent?
Sir, this IEEE we are planning, so for the same purpose we need your guidance, sir.
Mm-hmm.
Yeah.
So it depends actually upon the time.
Yes, sir. Yes, sir. If
I'm free, then only I will be able
yes,
to.
sir. I'll request you to be part of it if you have time. I'll be very thankful to you.
Let us not go for it. The advisory members' job is very huge, and sometimes
Yes.
People give us bunch of papers for review. So the review of papers will not be possible.
No, sir. Review. We will not request you review. We have some criteria of if review we are going to pay honorarium as well.
No, that is honorarium and other things.
Okay, sir. So not review, but in collaborating with IEEE journals, etc., we seeking your guidance.
Okay, so we will discuss that separately.
Yeah, thank you so much, sir. Thank you so much, sir. Welcome, sir.
Okay.
Questions?
So, any other queries? I think, sir, no more queries are there.
All right. So thank you very much, and
Thank you.
really very thankful and appreciate your patient hearing. Thank you very much.
So, thank you very much, sir, for giving your valuable time for this FDP.
Thank you. I really enjoyed.
So, it is requested to the participant, please rejoin us for the next session at 2:30 p.m. With the same link. This link will work for the next session also.
Vijay, sir, the feedback link for this, the attendance.
Attendance, yes, I already shared, sir. Let me share it again. Here it is. You can
Yeah,
mark your
fine.
attendance.
Right. Sir, I'm sorry to say this, but I found that there was some arrogance in the resource person, and probably this was not expected at this level, because all our faculties, when we are dealing with this, they should be a little bit considerate. The way he was talking with some of the contestants, it was, I mean, participants, it was a little bit arrogant. When we go up the ladder, the designation increases, people should be more humble actually.
Sir, actually, I'm not able to listen you clearly. Can you speak again?
Actually, the gentleman who was the resource person today was a little bit more arrogant, according to me, and I think so. While answering the questions, also he was, I mean, and until the face is visible, he will not be replying. All this, I mean, this seemed a little bit odd to me. Being a faculty, being a senior faculty, I don't expect that this should be some of the things that the resource person should be showing. And second thing is that, I mean, as we go, I'm also in a senior level designation. As I go ahead up in the designation, I should be more humble and I should be more considerate towards my fellow faculties.
Oh,
So whether it is IIT or non-IIT, it does not make a difference, but then the person makes a difference.
sorry, sir.
This is my
Actually,
personal view. I just shared it because I did not find that a little bit ego over there, which I thought I should bring to your notice.
okay, sir. Sir, we are calling you for your problem. Actually, hello, I, sir, Silas, yes, sir.
Yes, sir.
Sir, we are calling you for the talk.
No, actually, it was not with me. Actually, it was with Mr. Rajnish. Actually, I felt very bad for him because this is
Okay,
not the
okay,
way.
okay.
That's
I
it.
got now I got it, sir.
Personally, I had no issues. Actually, it was just that I thought this should not be the way normally people should be treated when they are attending FD.
Okay, sir. Okay, I got it, sir.
Yeah. Nothing from my end, sir. Nothing personal.